Hello everyone, it is Ryan back on the Syntax Byte, and in this Three.js video we are going to cover making a simple particle system. So the particle system we're going to make is going to be able to spawn and destroy particles. Each particle will have a certain lifetime and will have an update function that sort of transforms that particle throughout its life. These are just going to be simple 2D texture-based particles. So you can see an example here. Basically, the example I'm going to be making today is quite similar to the particles that come off of a Minecraft torch. So it's not a perfect replica, but it gives you an idea of kind of what we're going to make today. So we are going to be using a similar concept to what the particle examples on the Three.js website use, in that they use a points geometry. They use a points mesh to sort of draw the particles, but the examples there don't really emit and destroy particles. They're sort of just static particles. So we're going to have a full particle system here today that is going to emit and destroy particles just like you see in front of me, and work with pretty much any texture. So without further ado, let's just jump right into it. I'm going to go ahead and backtrack here and cd3 particles yt. And so the reason, of course, I have to do this little Ubuntu thing is because it won't open just the HTML file. So there we go. We'll go ahead and close my example. And so this is what I'm going to be starting with. I'll have this source code and the textures available for download on my website. I will do the written tutorial after this video. So if this video just came out a week or two ago, definitely just hold strong. And if not, the link to my website for the written tutorial with the full source code and all the downloads should be right below. So if it's not, just be patient, and if it's been more than 2 weeks since the video came out, yell at me in the comments. So yeah, basically this is what I'm starting with. This video isn't about putting a mesh and putting a texture on it, but to have the example look good, we sort of need that in here. So it comes with the basic orbit controls as well, which will allow us to test that our particles are responding correctly to camera movements and get bigger and smaller as we zoom in and out. So that's good to have in there. But really we're going to be focused on the particles today. So you will see that I already have this code up and running, and we're just going to hop in right away with getting our particles up and going as well. So in order to do these particles, we're going to add a basic particle class that we can then subclass to make specific types of particles with different animations. So I'm going to start by writing my Vertex Shader and my Fragment Shader. Now, if you aren't familiar with shaders, I'm going to do my best to explain this math to the best that I understand it, really. These shaders aren't super complex, but unfortunately we are going to have to use a custom shader material today. I'll try my best to explain the math, but where you guys want, you can just copy. But hopefully you'll get a basic understanding of the shader and know how to make some basic modifications to the shader in order to make sure that it's going to work for you. So to start, we're going to start with our Vertex Shader. Basically what a Vertex Shader does in WebGL, for those who may be unfamiliar, and no worries if you are, is basically it sort of positions what we're drawing on the screen. So in this case, we're positioning our point. And in this Vertex Shader, we're also going to specify the size of the point. And then there's a Fragment Shader, and a Fragment Shader basically just specifies the color. So we're specifying where do we want to draw the thing and what color do we want it to be. That's the gist of what these shaders are doing. So we're gonna start with kind of the most basic shaders here, and we'll add a couple lines to them as we go throughout the video. So I'm going to do a uniform float point multiplier. And basically what this is going to be is actually our like screen resolution. And that's going to make sure that when we change the resolution like that, see how the torch got smaller? It's going to make sure that our particles respond the same way. Then we'll do an attribute float scale. Okay. And so basically this is going to be the scale of our point. This is something we just need. So a uniform is something we're going to pass in once for all of our points. An attribute is something that is going to vary per point. Okay, so that's why the different use of those there. They're both floats. We're going to add another one later, but I'm not going to worry about it for now. We're going to start off with void main, the main function of our shader. In this one, we're going to say a vector for MV position is equal to model view matrix times vector for position 1.0. So, what does this do? The model view matrix basically matrix basically like positions the point in 3D space, okay? So that's basically what it does. Position is passed in by Three.js, I believe, as is, I believe, this. I don't believe you have that in regular WebGL. With that, we also need to apply the projection matrix. What the projection matrix does is basically it changes those coordinates. So this basically takes like the local coordinates of the object and puts it into like the world space, and then we need to take that world space and put it in something called the OpenGL clip space. And so the OpenGL clip space, it basically goes from, I think it's -1 to 1, and it basically is like OpenGL's coordinates, right? So obviously not everything in our Three.js world goes from like -1 to 1, so that's what the projection matrix is going to do. And the projection matrix is also responsible, I believe, for creating sort of that 3D effect, right? So we need to apply that projection matrix as well. So our final GL position, and this is a special variable that we set, basically setting the position that's gonna end up drawing to, is just now our projection matrix times MV position. So in theory you could do these all in one line, but the shader that I wrote doesn't have it like that, so we're gonna stick with this. So from there we need to just specify one last thing. We need to specify the point size, and so for this one we're going to use that point multiplier, which we'll pass in, times some really big number. So do like 1500 for our initial scale, times scale. So I just do this because we don't have to pass this in. We could just make it part of scale, but then if someone passes in 1 for a scale, they can't even really see the point. So it probably makes sense to have, they can always pass in, 0.1, and then they get 150 here instead. But it probably makes sense to have scale be something where, if someone passes 1, they can see the point. The point's a good size. And then finally, we divide it by GL position. .w. And basically what this does is it kind of takes care of making sure that as the camera moves closer and further away from the point, that the point appears larger or smaller. So that should kind of be it for that Vertex Shader. There's a couple more things we'll add as we go here, but that's okay. Then we want to do the Fragment Shader. So to do this one real quick, basically we can just hop right into, we're going to have a uniform sampler 2D diffuse texture. And basically what this is the texture we're going to pass in. We're going to make it uniform because all of our points in a certain particle system will have the same texture. So that's definitely, you could play around with that and pass a different texture for different points in the same particle system. So then you would want to make this an attribute and do something slightly different, but I will leave that up to you guys to do. Then we can do, basically we have to just apply the texture. So void main, we can do GL frag color equals texture 2D, and we do the texture, and then we do GL point chord. And this is basically a special built-in, I believe, that just sort of applies it to a point. Just does it right for trying a point. I mean, that's the best I can explain that at the moment, unfortunately. So that's basically it for now with our Fragment Shader. We basically just say, hey, use this texture and apply it for a point. And okay, great. It should do it for us. Alright, so with that we have our Vertex Shader and our Fragment Shader. I did want to go over those because I know if you haven't done shaders before, it's pretty confusing. You probably still don't even understand it, but at least hopefully you have a general idea of what each line does and what is probably going to change if you change one of the lines, right? So next up we're going to create our particle base class. In this constructor, we are going to take a texture for our particle system. Why don't we say particle system? That might make more sense. Just particles a little weird because we're talking about whole system here. We're going to do emit every. So this will be like how often should the particles emit a new one. And then we can do particle life. So when they're emitted, how long do they last? So we'll start with this.texture equals texture. This.emit every equals emit every. This.particle life equals particle life. And so we're just setting those basically. Now we'll set one more thing. This.last emission equals 0. So we're going to use a clock to sort of figure out our emission, and we need to know when the last time we emitted a particle was, so we know if it's time to emit another one. Then we'll do this.geometry. Remember, Three.js objects are made of geometry, and a material is a new Three.BufferGeometry, which is going to allow us to specify individual vertices. Beautiful. Then I'm going to do this.particles is equal to an array. We'll discuss this in a moment, but basically this is just internal to this class. This is not getting passed directly to the graphics card as it is, but this is just easiest way for me to manage my particles in the system. Next we need a material, so we'll do this.material equals new Three.ShaderMaterial. And so with this we do uniforms. And so what the uniforms are, remember, is we need a diffuse texture and we need a point multiplier. So we start with our diffuse texture. Now this syntax is a little weird. It seems to me I should just be able to specify it, but now I need to actually give it an object with a value and then do texture. And that's how that works. And then our point multiplier is going to be value, and in my case that's going to be window.inner height divided by window.inner width. So whatever you use in your, like you'll see on window resize here, whatever you're using as your camera aspect, it's like the inverse of that. So cool. Go ahead and do that. We want to give it our Vertex Shader and our Fragment Shader. We want to go ahead and specify a blend mode. You can play around with this. In this case, so it's just blending. I'm going to use Three.normal blending. But one thing you can try playing around with is doing Three.additive blending. And that will give you, when there's two particles on top of each other, they'll shine like really bright. You'll sort of be able to see the other one through the other one, if that makes any sense. In my case, I just want them to be normal, so I'm just going to do normal. We'll do a depth test can be true. We'll do a depth right can be false. We'll do transparent is definitely true. We have transparent textures, so that's good. And vertex colors is going to be true. So that is our material using those shaders that we wrote earlier. Alright, with our material in place, last thing to do is create the mesh. So this.mesh equals new Three.POINTS, this.geometry, and this.material. And finally, we'll just initialize a clock for it. So new Three.clock, and like I said, this will be used to determine when to spawn new particles and when to destroy ones that have been active for too long. Alright, so with that done, this basically wouldn't actually display anything right now because our buffer geometry is basically empty. So there's no points. So we basically need to add an update function that spawns the points. What I'm going to start with too is I'm going to set position. This will allow someone to set the position of the particle system. We'll do this.mesh.position.x is equal to position.x. Just setting position directly doesn't work for some reason. I actually don't know why. .y position.y. This.mesh.position.z equals position.z. Cool. Oops. We'll do a get mesh. So this is going to allow someone to get the actual mesh and add it to their scene. Return this.mesh. We'll do update aspect. And so what this does is anytime this needs to be updated, because this is a uniform, but we need to update it if someone changes the size of the window, right? In on window resize. So update aspect is going to do that whenever we call that, and so we can just throw that in our thing. So we'll say this dot material dot uniforms dot point multiplier dot value equals window dot inner height divided by window dot inner width. And that will update that when it needs to be updated. Of course, we have to call this for each individual particle system in order for this to work. All right. We're going to create a function. It's going to be called spawn. And inside of spawn, we will do this dot particles dot push. Of course, it's an array, so we can push a new object into there. And I'm going to have position be equal to 0, 0, 0. This is a local position for our particle system. I'm going to have scale be 1. I'm going to have alpha be 1. We haven't actually implemented alpha into our shaders yet, but we'll do that. And I'm going to have spawn time be this dot clock dot elapsed time. Wonderful. Okay. Finally, I'm going to have an update function. Inside of the update function, basically the main goal is when we subclass this, we're going to primarily use update to actually animate our particles, but the base particles won't animate. You could add a default animation or something, but just the way I found to do it easiest was just to leave the particles not to animate in the default way of things. So we're going to start by doing const elapsed time equals this dot clock dot elapsed time. Then we want to kill any of the dead particles, so we'll filter them out. This dot particles is equal to this dot particles dot filter and particle, and we want to filter for particles where elapsed time minus particle dot spawn time is less than this dot particle life. And so that will filter out any particles that should be dead, basically. Next, we want to see if we need to spawn any particles. So if elapsed time minus this dot last emission is greater than or equal to, this dot emit every, then we want to go ahead and do this dot spawn to spawn a new particle. Finally, we need to update the attributes in our buffer geometry. And so what we want to do is we want to do this dot geometry dot set attribute. First, we're going to set the position. And we'll say new 3 dot float 32 buffer attribute. And then we will do this dot particles dot map, and we want to return just the position. So we will do particle dot position, and then we will take this whole thing and we will do flat on it, because we don't want to. This is going to give us an array of arrays, but we actually want an array with just like every 3 is 1, but like 1 array. And so, and the reason it's going to know that every 3 numbers is going to be 1 is that we're going to pass in 3 here to specify the size. So that's that. We also need to do this for scale. And we will eventually do this for alpha, but we haven't implemented that yet, so we don't want to do this for alpha just yet. I'm just going to go ahead and copy that. It's basically the same idea, except we're passing scale, and we're doing scale. And scale is just 1. There's just the scale. It's just 1. It's a number. Finally, we have to say this dot geometry dot attributes dot position dot needs update equals true. And then it should update the position. I think we should actually have to do this for the scale too, although I don't have it in my notes. But we'll do attributes dot scale dot needs update equals true. It's probably kind of a thing where it works just doing this one because once it updates, it just updates. I don't know. It's a little weird that it worked actually. Okay, so at this point, what should we see? Well, we shouldn't really see our particles going anywhere, but we should be able to see them just spawn. So what we need to start by doing actually though is loading in our textures. And I do have a couple of textures ready to go for us to use for the particles. And again, those will be in the download below. So let's go ahead and load our textures into the scene. So what we should be able to do at this point is go down here. We should be able to say const flame equals texture loader dot load. And I already have a texture loader set up, so that's why I can do that. It's actually just called loader, so we're going to use loader. My bad. And we're going to go ahead and load flame.png. One thing is you want to do flame.flipy equals false. I don't know why they normally flip y, but it's default true. But I found that I ended up with an upside down texture, so I just turned it to false. If you turn it to false and find you end up with an upside down texture, just remove that line. So we can do flame particles. So we want to add a global up here for our flame particles. And so that's for our flame particles. So we can do flame particles equals new particle system. And we will pass in flame. The next one I believe is the life so this is how often we emit, and then the life. So we probably want to emit like once every like 1 second, say, and it's alive for 2 seconds. So there's kind of always 2 particles, except for at the start. Okay. Finally, I want to set the position. So flame particles dot set position. This is going to be a new 3 dot vector 3 0. Then we're going to do 2.5 divided by 2 plus 0.25 to put it at the top of the torch, and then we'll do 0. I kind of just figured this out earlier. This video is getting pretty long, so I don't want to go over everything. I'm sure you can figure out the position that will work for your particle system. So now we need to go ahead and do a scene.add, and we'll do flame particles.getMesh. So that will add that to our scene. We need to go ahead and add some of the update stuff in too. So we'll do flame particles.update aspect right here. And in our animate, we'll go ahead and do flame particles.update. And we should end up with flame particles. So I am going to cross my fingers here that we didn't make a mistake, but we most likely did. We did. We have a missing bracket after our property list on line 93. All right. Ooh, that's spicy. Because that bracket matches up. Oh, here we go. I put a semicolon at the end instead. Okay, this .clock.elapsed time is not a function on 98. I think it's get elapsed time for the function. Okay. Okay. Oh, we've got something going. This .clock.elapsed time is not a function in 98. Pretty sure that was what we just dealt with, so I think that's not... Must have something else now. Oh. This.clock.elapsed time is not a function. Well, I just did deal with that. Oh, I saw something about a buffer attribute. Oh. Dot flat is not a function. What? Oh, here's our problem. So I need to do it after the map. Good catch. I was trying to flat the Three.js thing. It doesn't work. Doesn't work. So. Oh, do I see a torch? Okay. So we see the torch, but I feel like we haven't got something that works here. Flat is not a function. It's still trying to do that on 106. No, I've changed that now. So I think we just need to clear the console. And refresh real quick. Okay, there we go. There we go. So vec no matching overload function found. It should be a vec4. So our shaders didn't compile. Okay, it should be a vec4. Let's see. Vertex attribute. Array 0 is enabled, but no buffer bound. What? I think this 3 here should be in here. Whoa. This 1 should be in here. And there you have it. We have some particles that have spawned. They're not doing anything at the moment, but we can see that the particles spawn. So a couple things to check. As we zoom in and out with the camera, it does zoom, like the size of it stays kind of the same. If we open the dev tools and we make sure that the particle shrinks with the torch, so that means our update aspect is working, and yeah, everything looks pretty good here. So final step here, apologize for all those errors, guys, but I did have someone comment on a video recently saying he does like to see me debug some errors. So for that person, there you go. I'm happy to do that for you today. So what we really want to do now is we want to go ahead and subclass this particle system and actually do some animations, some different types of animation for our smoke and for our rising particles, our flames, so what I'm going to do is I'm going to create a new class. I'm going to call it grow particle. It's going to extend particle, and we're going to do an update. We are going to do for let I equal 0, I is less than this dot particles dot length I++, and we're going to loop through all our particles and change the position and the scale a little bit. So we're going to do this dot particles I dot scale, or sorry, dot position 1, because that's the y position, plus equals 0.001. I mean, this is going to run every update, so you could do like times delta time here or something, but I'm just not going to bother. I'm not really that particular that if the particle rises slightly slower or faster than someone else's computer, like I don't really care. Then we want to go ahead and do the scale. And we're going to increase the scale as well a little bit. So it's going to start small and get a little bit bigger, and it's going to rise up a little while it's going. Okay? So we're going to do that. And then what we're going to do, then we have to do super.update to make sure the rest of the update stuff gets done. And after that, we should be able to just go down here, and where we have a particle system, we're going to do a new grow particle system. I just called it grow particle, and I extended particle. Sorry guys, that's what it's like in my notes. Grow particle system and particle system. Okay, so yeah, awesome. We should now have some sort of an animation if all went according to plan, and we do. For some reason, they are spawning like really like wacko here. Like there's like a million of them spawning, which isn't right. So the problem was that in spawn, I forgot to say this dot last emission equals this dot clock dot elapsed time. And so when we do that, they should stop spawning like 1200 per minute. And clearly it's like basically crashed my browser at this point. Good times. All right. So at this point, yeah, we can sort of see our particles. One's a little bit bigger than the other. Unfortunately, because they like die and spawn at the same time, it looks a little jerky. So let's fix that by just doing like 2.5 for the lifespan. So they don't, you know, yeah. So there we go. You guys can play around with this, of course, and see what works for you. So I did promise that we would add some alpha in here for the particle system and add our smoke as well. So to add the alpha, it's pretty simple. We're going to do attribute float alpha, and then basically we do varying float alpha to frag, whatever. Basically, it gets passed in here, but then we have to actually pass it back to the fragment shader. So we do varying float alpha to frag. Then we can do times of vec4, 1.0, 1.0, 1.0. So you can also multiply it by color and get a really cool effect. So if you wanted to like make your fire like blue, you could use the same fire texture, but then just like do blue here. Super cool stuff, but we're basically just going to do white, so it won't change the appearance at all. And then we're going to do our alpha to frag, so it's white, but then multiply by the alpha we want to have. In here, we just go ahead and do alpha to frag equals alpha, and that will sort of pass it through. And then at the end here, so we need to set up our attribute again. We just basically copy the scale. It's basically the same thing. And I did set these up to have an alpha, so that's cool. So it's particle.alpha, and that is that one there. And so now we should be able to actually change the alpha. So just to test it, I'm going to have all my particles be half alpha. And it works. Woo. First thing in this tutorial that actually works first try. I'm so pumped. Okay. So let's switch that back to 1. What we're going to do now is we're going to do a class. We'll do this like a smoke particle system, whatever. I try to name it after the animation because we're still giving the texture. Of course, we could actually take this subclass and put a texture in there, but I think it's actually just easier to pass in the texture still. Extends particle system, and in update, we're gonna go ahead and basically what I did with this one, it's kind of interesting. So one of the reasons I separated out that spawn function is so we can override that separately and then add custom properties onto that particle array. So we can do super.spawn, which is actually going to create the particle, and then we're going to do this.particles, and then we want the one that was just added, so we can do this.particles.length -1 equals dart x is equal to math.random times like 0.005 or something, and then times math.random greater than 0.5. If so, 1, else -1. So that means we get some negative numbers in there too. I guess in theory there's actually probably a better way to do that, but that's okay. This video is running long. Dart z, same thing. So we should get them darting in random directions. So we can basically just copy this update function here. Cool. So instead of doing position.1, I still want them to rise up, and I actually want them to rise up like quite a bit faster. We'll say 5 times as fast. The scale, I actually want it to decrease now because it's this little smoke thing, so they're going to kind of fizzle out as they go. And then I want to do this.particles I.alpha minus equals 0.001, and then I want to do this.particles.position 0 plus equals this.particles I.dart x, and we'll do the same thing for the z basically, except z is number 2 and dart z. And we should now have ourselves some pretty cool smoke stuff if we actually go ahead and add the system. So just like our flame one here, we have to go ahead and add in the particle system. So let's go ahead and add that global. So we have smoke particles. Cool. And through our smoke particles. I'm also gonna like just bump this up a little bit so it starts a little higher because I don't really want it starting at the base. It just kind of looks awkward. So then we can do scene.add smoke particles.get mesh. Cool. And smoke particles dot update aspect, and finally smoke particles dot update. Should get all the triggers in there to make sure it works correctly. Let's hope for the best. Okay. I think I see what's wrong. We actually used the flame and we wanted the smoke, so we need to add another texture here. We can't just use this one. We have to do smoke, okay. And although maybe it's not, and we can't use a grow particle system. Of course, we need to use a, what do we call it? We call it a smoke particle system. Yeah. Oh, we just died. This dot particles dot position is undefined. What? Whoops. Particles I. Oh, brother. It's been a real rough one today, guys. I don't even know if I'm going to use this video, but if you're seeing it, I did. Cool. I'm not really seeing the alpha fade. Oh, a little bit. Let's go ahead and bump that up. Cool, so that is basically our Minecraft torch. We can see the little smoke stuff. We might want to adjust the spawn rate on that. It's going pretty fast. Why don't we do like 2 on that? I don't know. Cool. And so this is basically the Minecraft torch I presented you at the start of the video. It has been a little bit lengthy getting here, but I hope the video was of value. As you can see, Three.js doesn't come with a built-in particle system. That's super great. Making one yourself isn't too difficult, but it does require diving into a little bit of shaders, and it can be a little frustrating at times, you know, as you get everything up and running. But the possibilities with something like this are truly endless. You can have the particles animate in any way you want. You can put a lot of effort in to make them really realistic, or in my case, I'm making a Minecraft torch. I don't need it to be super realistic, and so I don't have to worry about trying to make a realistic looking particle system in something like Unity look unrealistic. I can just have it exactly how I want. So there is an upside to putting in all this effort. But without further ado, it has been Ryan on the Syntax Byte. I hope you guys have enjoyed the video. There's been a lot of uptake on my previous Three.js videos, and so this is why I decided to tackle a particle system. I'm not going to lie, guys, this was a challenging video for me to put together. I learned a lot, having not actually done this before, but I wanted to bring you guys the particle system because I know there's going to be some people out there wondering about it, and you know, sometimes the content out there is a little sparse on this subject. So I hope you found that this video was one that was worth clicking on. Anyway, guys, without further ado, definitely leave me any questions or comments down below. Like the video if it helped you out, and I will see you in the next video.